Ladies and gentlemen, welcome back to yet another tutorial. It's been a while since my last one, so bear with me. So what I want to do today, or rather for this tutorial, is make a material that changes how much it refracts in its relation to the player and the distance between them. So, what I have open right now is a tab on the VDC for the refract material and the shader. And really not much on the page. Yeah, okay. The more important tab I want to show you guys is right here, list material proxies, which I'm going to use to make the material react to the player. So, some things I'm probably going to need is, for one, let's see here. Not the player position. Yuck. Player distance. Player proximity, there we go. There we go, distance, keyword. So, I'm going to be using this to drive how strong the refraction is on the texture. Actually, the material, correction. The texture is actually VTF, materials VMT. A bit different. So, I'm going to be using Notepad++ for this, and fortunately, there is a language pack for it that you can install that'll highlight keywords. So it's nice, but since I'm using a dark color scheme for Notepad++, I had to change some colors around. So if yours doesn't look exactly like mine, don't fret. It's alright. Speed this thing along, I'm going to actually take the observation glass that you get from observation rooms, all the glass that you see in them, and just copy the values over into a new texture or text file right now. Let me save it, and let's see here. I don't want to put this in mat testing. Alright, distance proximity. T and bind it in quotes. There we go. Syntax highlighting. Awesome. Okay, so this alone is going to give me a texture that'll pretty much emulate what you get on the observation room. Now, I've already done this a couple times and wasted 5 hours trying to get something working, so I'm going to go ahead and jump in the writing material proxies down. So, first thing I want to do is add a proxies section to the material. And actually, it's not going to recognize it unless I do that. You don't have to bind everything in quotations, though, just so you know. Right here, refract tint, color value, I think it has to do with scaling, which is why 111, 0 to 1 range instead of 255. So that has to be in quotes. There's a space between it, or else if you don't put quotes there, the source is going to be very upset with you and not love the texture. So, first thing I want to do is add some scratch variables. These are kind of basic scripting, so you don't really have to worry too much about it if you're used to doing scripting in, I don't know, Unreal or PHP. Along the same lines. If you've never done scripting before, don't worry, this is not going to be very complicated. So, first thing I'm going to grab is player proximity. Put that in here, drop that down. Now for scale, I'm just going to keep it at 1. Don't need the change right now. And let's see here, was one result var, I believe? Yep, result variable. And what I want to put this in is some scratch variable. I'm going to call it player distance. Oops. Player, not parentheses. Now, because I have a reference down here, I have to put the local variable up here, so that way when the engine drops into the proxies list, it knows that this exists. Yeah, local scope, global scope. Everything here is pretty much global scope, so I'm going to use the terms interchangeably. Player distance, I'm going to set that to 0. Now, since this is going to be based on distance, I'm going to have something to compare it to. So I'm going to set a max distance then. Let's say 256 units, hammer units. That sounds about right. And something I'm going to need later is, I think the term is normalized. This is when I go through it, it's going to take it from the player distance and the max distance and convert that to a number from 0 to 1. So set that to 0 as well. Now I have a player proximity, that's good. Now I want to divide the player's distance by the max distance to get me that number from 0 to 1. To do that, if I scroll up over here, there's the divide material proxy. So I'm going to go to paste that in. And our first source variable is going to be the player distance. Do note, these are case sensitive. So the second one, I'm going to have it be the max distance. And this is going to be stored in the normal distance. Now this can get me values I don't want, so to make sure it is between 0 and 1, I'm going to go ahead and clamp the value. So if it's below 0, it becomes 0. If it's greater than 1, it becomes 1. So I'll just go ahead and copy paste these in here. And of course all my tabs are off. So the minimum value I want is 0. The maximum value I want is 1. Let's bump these over just a little bit so it looks a little more coherent. Looks prettier. So the value I want to clamp is the result of the division that I have up here. Oh, and also I should probably say that when these are executed, it's from top to bottom. There's no loop statements, there's no ifs, whiles, for loops. Everything you see on here is pretty much all you have to deal with. So if you want to do conditional statements, you're going to get a little tricky. Be very creative. So, the normal distance here. And after I clamp it, I'm just going to put it right back into normal distance. That should be fine. Actually, you know what? I'm not going to be doing anything else with the normal distance, so I'm going to just skip a beat and put it directly into the refract amount. Now, that done here, paste, click save, move this over, and let's maximize this. So, I'm going to create a brush. Here's a standard old brush. However, as the Firefox window tab did say, you will need to apply this to an actual brush entity and not a world brush. I did a little testing before this, as I said earlier, and font details seem to be okay, but I was messing with material proxy modifiers, and they require an actual brush entity, like func brush. So I'm going to go ahead and do that for right now. Yep. Right here, and bring down the grid size just a little. Create a no-draw brush. Let's bring it up a bit. Okay. So I'm going to tie this to func brush. And don't have to give it a name, but I might as well. Material brush. Okay, now I'm going to go in here and let's see, I saved that in mat testing, right? Should come up here, change alpha, no, proximity refract, no, distance proximity, there we are. So I'm going to fit this to the brush, and let's compile it and see what happens. No lighting, so there's just no lights. Any minute now. And I'm running Afterburner, that's what the numbers in the top left are for. In pretty much every DirectX enabled window. And here we go. The further away I get, the more it refracts. What I want to do though is actually reverse this. I want it so the closer you get to the material, the more it refracts. The further away you get, the more normal it looks. To do that, I'm going to quit out of this. I'm going to change the numbers around here. Before I had it straight in the normal distance. What I'm going to do is put it back into there. Create a new variable up here called 1. And give it a value of 1. Next up, I want to have a subtract. Because I want to flip the value, and I know it's going to be between 0 and 1. So if I want to reverse or flip it, I just have to subtract whatever I get from 1, and that'll give me the opposite number. I know there's a term for that. It's escaping me now. I think it starts with a C. But anyways, so results. Nope, subtract. There we go. Subtracts the second variable from the first. So, add a subtract here. Source variable 1 is going to be 1. Source variable 2 is going to be, not subtract, the normal distance. The result variable is going to be the refract amount. Save that. Recompile. You don't have to recompile every single time you make a change. In fact, I'll show you that in a moment. Yeah. Okay, let's see here. There it is. Load. So, here we are. I'll zoom in, and you can see where the texture is slightly from this little border around it where it's all fuzzy. That's from the blur amount if you look on the left over here. I have a little blur going on. So, if I move in closer, you can see that it is now getting a stronger refraction. And it calculates your straight distance, so you're pretty much calculating in a sphere. So if I enter the sphere 256 units away from the origin of this entity, it'll start refracting. Now here's what I mean about it not having to restart the game or shut it down or recompile every time you make a change. I'm going to modify the tint. Go ahead and take out the green value. If I go over here, I can do matte, reload all materials. And there you have it. Red and blue are turned all the way up, there's no green. So, you can also tie this to the player's proximity as well. So let me see here. I've refracted them in here. So what I'm going to do then is I need to copy the refract amount to another variable. To do that, I'm going to use equals. It's right here. The copies the value of a variable to another. And hold that thought just a minute. My screen capture is about to stop itself. So, short blip, and blip's over. So, yes, equals. For you, it's been less than a second. For me, it's been about 20 minutes. So, source variable, sorry, so my source variable is going to be the normal distance. Change that out, there we go. No, actually, I don't need to do that. I lost my train of thought. That's okay. Let's take that. Actually, yeah. The result I want is in here. So now, what I want to do is change. Let's change the green value. Why not? It's already 0. So the result is going to go in like this. I'm going to have the name of the array, and then I'm going to specify which element in that array, 0, 1, or 2. There are 3 elements in there and they're 0 indexed, so that means counting starts at the number 0. Hence going for 1 instead of 2. Now because this is an array, or it's going to go into an array with specifically this object in it, I have to enclose this in quotation marks, or else I'm going to get an error in the console and it won't work. So in that time I did shut down Portal 2, so I'll just have it recompile, zip along, any minute now. So we should see the green changing color. And there it goes. From far away, it's not refracting, and it's purple. If I move in, it starts refracting and returning to a whitish color. It won't get fully white because I don't have no clip on. I can't pass through to the origin. But yeah, that's pretty much it. And it's a little extra for this tutorial. I'm going to cut a side out of this. Let's maximize here. The texture the material proxies can also work on models. And to demonstrate this, I went ahead and hexed a model, hexed the observation glass model, and created a new instance with that in for the observation room glass. I wouldn't really recommend doing this because if you do any numbers generation, say creating a random static number using the player, generating numbers using the player, like their position in the world, their distance, their view angle, as soon as you look at the model, it'll crash the game. It's just not recommended. So if you're going to modify observation rooms, I suggest you stick with brushes and just copy the texture. You'll have to go into the use GCFscape to open up the vpacks and grab it from there. Right, labs. Nope, not lights. Labs. Labs. Color shifting. Tip it around. Not a big fan of this particular one because of the huge extra brush here. Had a couple instances where that was a problem. So, I mean, it's physically necessary if you're going to have this big opening. Ooh, I should probably just do that. Doesn't really matter any outside facing areas here, any of these. If they're facing the void, they will not get rendered. So, not a big issue. And just for kicks, I'm going to compile with light. If I bring a portal. Oh, and I just messed up the color. Oh, and yeah. So I'm going to go ahead and find this material again and show you what I'm doing in it to make it shift color. I can tell you right now I'm using a sine wave generator to do that. So it's going to be models, props lab. Yeah, as part of the hexing process, I replaced the I with the 1. That way I could create two quote-unquote distinct models. So right here I have just the basic offset. This is initially generated using a... let me pull it up here. Number generation made using... oh, come on. No, it's here somewhere. There we go. Entity random. But as soon as, like I said, as soon as you look at the model, it crashes. So I had to set the offset manually. Of course, I could just put a plain number in there. Not sure how well that would have worked, actually. But there we go. Sine period. How many times it goes. If you've done any trigonometry, you know what the sine period is. I'm not going to go into it. It's been way too long. So I have 3 sines going off here, each changing the red, green, and blue values. So you can see they are, except for spacing, they're pretty much the same except for the proxies I use and some of the local global variables. You note that it does not affect the lighting, once the lighting is baked and controlled by an actual point entity. Or I think, yeah, this one is a point entity. Some of them are actually brush-based lighting. But yes, you could, I don't know, use a color blend or something to modify, not color blend, a timer or some logic cases to change the color of a light. Projected texture actually would probably be safer, and make it look like they're having a rave in the back room while you're busy testing. So with that, I'll wrap this tutorial up. If you need any questions, if you have any questions, then just go ahead and post a comment, send me a PM. Well, not always here, but I'll get to you as soon as I can, as soon as I remember to check my account. So, with that, I'll log out.